Okay, so last time we started with MATLAB fundamentals. Basically, our first topic is, if I'm going to do anything, how do I either input data into MATLAB, and data often comes as some sort of tables or vectors. Okay, so I need vectors and matrices, or I create them in MATLAB itself. Now, so who is going to tell me? I'm going to start again up there. So basically, if I want a matrix of size 4 by 5, and I want random numbers between 0 and 2, what am I going to type in to get such a matrix?
First you want to type rand.
Rand? 4 by 5?
That's between 2 to 1.
Yes, between 0 and 2.
I don't know about
So what will this give me? Let's get there.
just random numbers on 4.
Between 0 and 1.
Yeah.
So how do I scale them to be between 0 and 2?
Multiply a by 2.
There we go. And that'll do it. Okay. Now, if you also needed to shift them a little, so if you wanted between 1 and 3, then you would add 1, right? And you can shift them. So what I'm doing here, the output here, this is a matrix, right? This is multiplying by scalar. We know how to do that. And when I say plus 1, the way MATLAB interprets this is it's going to add 1 to every. This is basically MATLAB being nice, okay? It's going to add 1 to every element of this matrix. If you wanted to do it on paper or mathematically, formally, 1 is a scalar, the other part is a 4 by 5 matrix. Technically, you can't do that operation. This is just MATLAB being nice, okay, and making it easy to do things. Now, if I wanted to be mathematically correct, what would I have to have here? Next. So instead of 1, what would I have to have? Yeah, about adding this addition of these two objects. One is a matrix, one is a scalar. I technically cannot do that. Mathematically, I cannot do that. So what would this second object have to be? Instead of 1? A matrix of the same size. So how would I create a matrix of the same size that has only 1s in there? I could type it in, or I can say 1s of 4, 5. This is one of the built-in functions that I introduced last time, so this is a review. Okay? So both of these are built-in functions, meaning that they already exist. I just need to know how to execute them. Okay? And basically, this is going to create a 4 by 5 matrix, and it's kind of useful when I need to just create some input. So this basically gives me a similar thing. Now, next person, it seems that when I executed this and that, I got 2 different results. Why do you think is that? We didn't cover that last time. This is now a trick question. So this random function is a random number generator. So every time I do it now consecutively, it's going to give me a different input. Okay? The reason why that is useful is because you will get to that in geostatistics in your coursework. But essentially, if I wanted to investigate properties of a reservoir, for instance, okay, we call that you can create one of these matrices. Let's say that we are actually between 0 and 1. Okay? So I'm just going to do random numbers between 0 and 1. This could be porosities, okay? So this gives me a realization of these porosities between 0 and 1. To actually see what can happen in a reservoir, I need multiple realizations, and I need to run my simulations for all those realizations to get sort of some more cumulative output of what could be going on if I don't have enough data. Okay? So basically, this random function is basically designed that way, that gives you realization of random numbers between 0 and 1 because there is no precise answer. Okay? You can just statistically accumulate a lot of answers that are in that range. So that's why rand works that way. Okay? And how am I gonna, so let's say that I didn't know what rand was about. How do I find out more?
Help.
Help. So I can type in help and name of any function. Okay. So then you will get, well, sometimes much more text than you're ready to read. This is function that has multiple. So technically, I could have just said rand of 4, and then I would get a 4 by 4. Or otherwise, I put the full information. I could have a 3-dimensional matrix. Okay? Two dimensions is 2 dimensions. I could actually have a box-like volume of data, of porosities, or my reservoir. So I could have actually done random of 2, 4, 5. Okay? And then it's a little harder to print out. Okay? So what this means is that actually I'm just going to do random of, it's going to be 4, 5, and 2. Okay? Then this is 4 by 5 by 2. So this is now 3-dimensional data. I have 4 by 5 layer, and then I have one more 4 by 5 layer for a total of 2 of them. Okay? And I could stack as many as you'd like. That's how you get a 3-dimensional reservoir. Okay? So this would be a simplistic model of 3D. So technically, MATLAB has no problem creating 15D matrix. Okay? Matrix with 15 dimensions. You will have trouble visualizing it. Okay? It can handle in an abstract way whatever you put in, but you will then have issues looking at it. Okay? And at some point, we're all going to run out of memory. And we'll get to that later. So it's not so easy to, if you think about points, let's say that this is 1,000 by 1,000 by 1,000. Okay. 1,000 by 1,000 by 1,000 is 10 to the 9. That's 1 giga. If I'm using 1 byte for each number, it's going to be 1 gigabyte. Okay. What's the memory on your laptop? But just by looking at it, likely 8. 8 gigabytes of working memory, maybe 16. Okay? So I know that because Apples don't produce anything larger than 16 gigabytes. Maybe there are some PCs that have 32. Most likely laptops go up to 32 gigabytes right now. You have a bigger one?
I mean, I have hundreds of gigabytes of music.
That's storage. I'm talking about working memory.
Is there a difference?
Working memory, yes. Working memory, great question. So working memory is what you call RAM. Okay? So that's the memory that is operating your machine right now. And what you can open at one time. Okay? That storage that you have is not open right now. And when you open it, you open one song at a time. Maybe you load 10 of them in a queue, or 20 of them in a queue, and then you listen to that queue. Right? So what's loaded in your memory is only part of the memory. So that's the permanent storage. You can have easily, how much you probably have? 5
terabyte.
You have a terabyte. You could easily buy a 2 terabyte, 3 terabyte extra disks. You can stack up disks on your desk at home, right? But then you have to just plug in one by one. But that storage is passive. What you see open right now, and any, so is MATLAB open? Maybe you should have Word open, some other program working on it, you know, your browser. That's what takes the current memory. And sometimes you overload it so bad, your computer slows down. That's this temporary. So whatever I'm computing on right now, I have to have that in my working memory. And that's problematic because you need fast access to it. Just because, think about it as a library. Okay, there's University of Texas libraries are fantastic. They have lots of books, but I gotta walk to them, then go to first, second, third, fourth, fifth floor to get my find it, get back down there. Just like that in your memory, you have to get to it, and that can slow you down. It's not as slow as you walking, but if you need to process a lot of data, then that definitely slows. So we cannot keep all of your music or whatever files you're storing. I'm extrapolating here, I don't know what you're storing. But essentially, you cannot keep it all in the working memory. So what I want to point out is that something, as we go along, it's something that you will eventually hit as a problem, because no matter what in petroleum engineering, you're going to have large data. Okay, 1,000 by 1,000 by 1,000, it's nothing in terms of a reservoir. Okay? It's could be, if you have 1 foot, it could be data that is 1,000 by 1,000 by 1,000 feet. That's a small reservoir. Okay, that's nothing big. And if you need 1 gigabyte, but typically just to load it in a memory, you need at least 1 byte per point. We will get to numbers later. You need probably more than 1 byte, 4 or 8. So that's 8 gigabytes right there. So let's actually just try to, let's say A, let's try to request, see what you get. And please put semicolon after that, otherwise it's going to try to print everything on the screen. That's too many numbers to print. Give it a try. My computer is attempting to allocate 8 gigabytes. It might take it a moment. Huh? You press enter. It actually did fit it in. So right now, I have reserved 8 gigabytes of working memory. If I do it once again, I'm done. I have 16, okay? Or I might hit a problem. It might not do it at all. Boom. Requested array that obviously exceeds what I can do. Yeah? So that's something that I'm going to point as we go along. So it appears that you can do everything until you cannot. Okay. And what we do often is that's what we need these days parallel computers for. Parallel computers are pooling multiple computers at the same time to share the memory and try to divide a bigger problem into small chunks that individual processing units can process at the time. All right. So this was a very brief review. So now let's review and pointing out this is different type. Now let's actually move on to where we stopped. So this was our last exercise last time. Now we will continue with some useful functions in MATLAB for creation of these arrays that we might need in our problems. So what's nice about MATLAB, so this is, can my next victim explain to me what is written here? What is PI? So that's a pi, that's a number pi, and it's already reserved under that name in MATLAB, so you can just refer to it, okay? Equally spaced. So basically every pi over 4 give me a number, and that's what this is 0, this is pi over 4, this is 2 times pi over 4, 3 times pi over 4, right? So basically give me numbers between 0 and pi that are equally spaced, and this is the result. Now what's not very nice about MATLAB, I know that cosine function is a mathematical function that is already built in. Not only that I can evaluate cosine of pi, or pi over 4, I can actually evaluate cosine for all of the members of my array, all of the elements. Okay? So when I type this in, first type this, when I now say y is equal to cosine of x, it's going to compute it for all of the elements of this array, which is really cool. Saves a whole lot of typing. Okay. We will in this course actually learn how to both make it go through every element and do something, because that's what you need to do in most programming languages. And we will use this because it's called vectorization, and it's simply very useful. I could have actually executed this on a matrix as well, and it would work just as fine. Yes? No, this is, great question. So x is equal 0. This is really pi over 4. So what this means, technically, if you're confused who is coming first, who is coming second, put parentheses, okay? Otherwise, inherently, this division has precedence. It's the operation that is going to be executed first before it takes this colon into account. Okay. If you're confused what would it do first, then put parentheses, and that you will make sure. Okay? So cosine of pi will actually work. Oh, cosine of pi, cosine of x. So again, I can execute cosine both on a single number or a scalar and on a vector. Okay?
Just we put it 0 by pi by 4 by pi. What does the 0 denote?
So 0 and pi are my end members.
Range.
Yes, range. So every pi over 4 give me a number. Okay? So that is called vectorization. You can again do something for two matrices. So if you type in two matrices, and we know that if I just type in A times B, okay, it's going to give me matrix multiplication, which has its own inherent rules how you're supposed to do it. If you actually want to do something element by element, so I want to multiply first element of A times first element of B, then first element of A by second and third and so forth in all of the rows and all of the columns, then I will put dot times B. So give it a try. Let's type in A. You can type in any A, any B. I'm going to be lazy and use cut, copy, paste from my PowerPoint presentation because I can. Do you notice how my computer is slow? It's slow because it's trying to handle this large memory, and right now it's replaced that large, so I have just now effectively killed that large matrix that I created, which is good. It's not going to slow my MATLAB down. Okay, so if I do A times B, that's matrix multiplication. Okay, that takes in the first position, first row of A, in a position 1, 1, it's going to take row 1 of A and column 1 of B. In position 1, 2, row 1 of A, column 2 of B, and do the dot product of them, and that's here. So that's the whole matrix multiplication. But if I want element by element, and what makes sense for me, only I know. These are the two options that I can do. So you can see now my next victim. So how will if I wanted to store this result, what would I do? So that I can refer to it later.
Well, I have it pulled up in my workspace. So is that?
So right now, this is what in the workspace, this result here. How is it called? Answer. But if I want something more permanent, what would I do? I would give it a name.
So would you go new?
New, sure. Want to call it new? So this is my matrix new. And now if I want element 2, 3 of new, what should I do? What is element 2, 3?
25.
2, 3.
Or, sorry.
24. Yeah. So this is how I grab something. A, store it. B, refer to it later. Okay. Now, next thing that I might want to do, and we will do this a lot when we are reading input from a given text file, I might want to reshape my matrix. Okay? So let's say that I have a matrix. In this case, I have a matrix that is 4 by 3. Okay? And it's actually the way MATLAB really stores it in memory. It stores first, column first, then second, then third. Okay? When it's kind of fitting it into memory. Now if I wanted to just reshape this matrix into some other shape, as long as I have enough elements for it, I can just say reshape this matrix as a 2 by 6. 3 times 4 is 12, 2 times 6 is 12. I have the same number of elements. And how am I going to store these elements in B? I'm going to go 1, 2, okay? And since I'm requesting a 2 by 6, then I'm going to break there. And the 3, 4 will be in the second column of B. And 5, 6, 7, 8, 9, 10, 11, 12. So this is just the rule how reshape works. Why, you might ask? You'll see in your homework. So it's just sometimes the data we get, okay, is simply in certain order that we didn't put it in, but we need it in a different order. So we need to have tools to reshape it. MATLAB has this tool. Some other programming environment might have a different one. You have to adjust. But either way, you as an engineer are tasked of reading that data and doing something with it. And before you can do anything, you gotta shape it in some sort of form that your functions are working with. So let's give this a try. One, 5, 9, 6, 2, 6, 10, 3, 7, 1, and 4, 8, 12. So this is my A. Oh, whoops. 11. All right. So now if I said B, reshape whoops. Oh, this is a great point. So I had a typo, and I put 216. Then it tells me that number of elements must not change. Well, I don't have 2 times 16 of them. I don't have 32. You learn on mistakes, by the way. You never learn if you just type in everything as well. And you can do anything else. You could do 112. Okay, you could do 12, 1. Do you think that I can do 11, 1? Based on what I said, no, but you actually never know. Sometimes MATLAB makes things up anyway, but here it says, no, 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 I have strict rules. Now, a programmer behind this might have said, well, you have enough elements, just use the first 11. And that's a possibility. You don't know. You often need to test. Okay? And I can tell you from experience that MATLAB, in my lifetime, has changed and has been changing. And it is getting kind of nicer and nicer and nicer. It accepts more kind of bad input from users as you go along, okay? So there are certain things that I don't even know, like that I couldn't do last year, but I can this year without it yelling at me, okay? So you often need to test and expect that again, there was a human behind it programming it, and that human had something in mind. And that might not be what you have in mind. Right? One cool thing, and that's the same as, so if I just want to put the matrix in a column vector form, just dump every column after each other, then you just do this. So this is just a shorthand notation for essentially reshaping of this. So this reshaping is the same as if I've typed in the following. So colon is basically a shorthand notation. Okay? So I get the same result. Okay, this and that. You good? Did everybody get a chance to try before I move on? All right. Great. So now I'm ready to actually start saving whatever it is that I have. And there's various ways I can do that. The easiest way, okay, is, so I have certain, there's multiple ways, and we're going to learn multiple ways. The easiest way is to go what I call a MATLAB route, okay, and save a specific format, MATLAB format for your data. And that's going to preserve all of the variables that you have in your space. Okay? It's going to kind of preserve them in a very same format. You're going to save that data. You're going to get a file that is .mat, M-A-T file, that is specific MATLAB file, and that can be opened only by MATLAB or some program that knows how MATLAB functions. Now, if you want to send that to anybody in this class, everybody in this class has access to MATLAB, so that's great. Okay? So they can just read that data and work with it. Now, that's sometimes the case, sometimes it's not. Okay? Sometimes you're sending it to somebody who doesn't have MATLAB, or that somebody, maybe your manager, is requesting a very specific different format, or something that can be easily read by a text editor, so just text data. In that case, you need to know how to save. So text data is sort of the simplest way to actually write something down. So that's the second way, basically conceptually. And then the third way is that essentially when I actually look at the memory and how much disk space I have, sometimes my data is way too large, and this fancy schmancy MATLAB format is just taking too much space. So you have to actually go into cost saving and save, just strip any extra information and save just numbers and nothing else in a most cost-saving way possible. Those are binary formats, and those you cannot open in a text editor. You can, but you will see a whole bunch of zeros and ones and strange characters. Okay? So you have to then open those and read them directly from. Okay. So those are conceptually the three ways we have to save. Yes?
Does saving your file also save the
No. So command window or anything, that's what you save with diary. You can also save it in a script. We're going to get to that later. So there's multiple ways that you can save your commands. Okay? But this type of saving is really just taking variables that are in your workspace and saving only those, or a selection of them. So these are conceptually my three ways to save data. Let's actually now get through all of them. So technically there's save and load. These are MATLAB specific commands. Okay. So save, just save in a file name will save everything you have right now in your memory. So let's do this. We actually have a whole bunch of stuff in the memory. It's this, right? I'm not going to create new stuff in my memory. I'm just going to work with what I have. So I'm going to have, say, save, and I'm going to call it all variables. The name is up to you. So this is name of the file that will show up. So right now, there are no files in my current folder. Okay? So when I do that, you will see all variables .mat show up in your folder. So these variables, 1, 2, 3, 4, 5, are saved in that file right now. Let's say clear, and I'm going to clear all. Clear actually clears this memory. So all of them will disappear. If I now want to refer to A, it's going to tell me that it's undefined. I have just deleted it.
Is there a difference between clear and clear all?
I think clear might clear all by default. I put clear all because I want to make sure that I'm typing in what I want to clear. I can also say clear and just clear one variable. So clear A. Okay? So if I say A is 1, okay, I can just say clear A. Okay? But I saved the data, so I'm safe. I can load all variables. And now I have all of them in the memory just like they were. There was a question about my commands. I don't have the commands. They don't travel with. But commands, since I didn't close MATLAB, I can still access by going with my arrow key up. If I close MATLAB, I lost my commands. I have them in history, though. So there's a command history right here. History is limited. It's not that bad. It's something like 5,000 lines. Okay? So history command is actually, whoops. Oh. Well, I guess history has changed. It used to be that you could do history and you will get them, but you can access them here from this. Huh. And apparently history, so this is what I'm talking about changing MATLAB. History command has moved to a toolbox that apparently I don't have. MATLAB wants to sell me. I'll actually investigate, maybe there's a replacement. But anyway, you can actually have command history right here, and you can access it, yes?
When you loaded it, what's the purpose of putting .mat?
None, it's actually, if you don't put it, it's going to assume it's .mat, because load works with. So let's actually try clear all. Let's just do it did the same thing. So .mat is, like if you don't write it, it's going to assume it. And I mentioned already that I'm old school, so I typically type in everything so that there's no confusion in communication between me. Because these things are the ones that are kind of becoming nicer and nicer and are changing over time. Okay. Now, I could have also said, oh, and you can do help load, of course, if you want more details. Okay. You can also, oh, that is help load or help save. Okay. So if I do help save, you will see that there's all kinds of, sometimes versions change, so you could actually specify the version of MATLAB. Typically, software, good software, is built so that it's backwards compatible, so that in version 10.3, I can read something from version 9.2. Okay? But in version 9.2, I don't know anything about the future version of 10.3, so if my file was saved in 10.3, I'm not going to be able to read it. Okay? So sometimes you actually have to work with those. So you could specify the version and all kinds of details. And that's typically best not memorized, but really checked on the spot. ASCII refers to a plain text file. We're going to get to that. So that's one of the options that we're going to use. And then you could just save certain variables as opposed to just all of them. Okay? So you could just do save A into A. So that should actually, let's see, save just A into a.mat. Okay. So again, this is just as a review and for your documentation so you can study from it. You can do just save file name, or you could specify variables you want to say. You could also specify that you want them in a text file, not the MATLAB file. So these are the basic options we're going to work with. And text file you can open in Notepad or any other text version of the file. So let's exemplify that. ASCII. Okay. So now my A here is a text file. These are very subtle differences. Does everybody see my screen? Well, so this A here, the first A is this text version, and if I open it, MATLAB editor, just like any other text editor, can read a text file, and this is what I see. So it's 159. It's doing the format of a number, the general format of the number, but this is still 159, 261, 26, 10, 3, 7, 11, and so forth. Okay, so this is how it's saved as a text file. If I open this one for reading, I can try. It's a very good question. Oh, so if I click on it in MATLAB, okay, MATLAB will be smarty pants and it's actually going to load it. It's going to recognize that this is MATLAB format and it's going to load it. If I was in a regular text editor, I would open it. So let's try type. This is essentially what's supposedly stored in that file. So it's cryptic because it's binary. It has some formatting things that I cannot read as text. Okay. Is this clear? So any file that has an extension that you can recognize, .jpeg, .tiff, .doc, .docx, and so forth, those are formats, okay, and they have certain order of the way, in the way they store things, and you have to know the format in order to read it. Text format is the simplest thing. It's just interpretation of characters as text, and that's kind of human readable. Everything else is not necessarily human readable. All right. So loading, just as a summary, I can load MATLAB type of file. I can also load text file. Okay. Clear all I use to clear all variables, or I can specify which variables to clear. Now if I load a text file that is just text file and not MATLAB, okay, it's just going to read it into a matrix. Okay. So let's actually do that. So I'm going to clear all again. Okay. If I just load a.mat, which is my MATLAB smart file, okay, I'm going to load it into A, okay. But I can also load it as A dot oh, it's called A, never mind. Oh, A is not a good, let's save something as a save. I have A, I'll save something else to it, B as 1, 2, 3. Okay. And now I'm going to say save A, B.txt, A and B, and save it as an ASCII file. So what I'm typing in here, and I want to exemplify these subtle differences in how you save it. So this is my file name. This is what I want to store it in that file, both of these variables, and save it as a text. So I can see my ab.text here. When I open it, I will see that A has been saved here, and B was saved right after it, without knowing who is who. Okay? It just saved the numbers. You have to know where you stored what. Now if I want to load it, so when I say load, ab.txt, it's gonna load it, but my AB has showed up, and it loaded it in AB, didn't know any better. It kind of lumped it together, so I don't know which part of it is A, which part of it is B. So do you see the difference between the smart saving with MATLAB saving all of its variables the way they are with their names, versus this is just numbers preserved in some order. Okay? And order depended on you. How did you type in? I typed in A, then B. If I typed in B, then A, then B would be first, and A would follow. So that's some details to be wary of. But again, this text format is the fundamental format that you can send it. You can email it inside an email, and person will be able to read it. Okay, and we will see example in the homework with vellog being actually a text file with some formatting at the beginning. Yes?
What is the difference between saving and it's just .txt versus .txt/ASCII?
So this will. So this is just the name, whatever name I give it. Okay. This specifies text, just text only. So save just numbers as text that I can read. And I can read it, I can open it, right? I can open and visually read the numbers, as opposed to having some cryptic stuff in there. Questions? Yes?
When you type in A, B, you're saving those variables together one after the other?
Yes, yes. And if I typed in BA, it would save them in a different order. Okay, so there's a lot of subtle little things built in there. Okay? All right, thank you. I see you next time.